Quantum computing is no longer a futuristic fantasy. It's here, and it's being put to work in a variety of fields. One of the most promising areas for quantum algorithms is in analytics. The idea of using quantum computers to crunch huge sets of numbers and variables and then using those answers to drive business decisions sounds like a dream come true. But like any powerful tool, quantum algorithms present us with ethical dilemmas we need to address head-on. In this episode of Data Skeptics, we are going to discuss 3 issues that every business leader needs to be aware of when considering quantum-driven analytics. The first is bias. Even if a quantum algorithm is developed to be as neutral as possible, the data it's trained on will almost always reflect some kind of bias. And that's a problem, because as we've seen from debates around AI and machine learning, biased algorithms can easily end up perpetuating and even amplifying societal biases. Imagine, for example, that a quantum algorithm is used to analyze hiring data for a company. If the data reflects gender bias, the algorithm will learn those patterns and may even end up making them worse. This can create a real problem for businesses who need to be able to trust the data they are reusing to make decisions. After all, if you're using an algorithm to decide who to hire, you want to be sure that it's not just perpetuating old biases. The second issue is transparency. Quantum algorithms are often referred to as black boxes, because like many machine learning algorithms, they can be very complex and difficult to interpret. This lack of transparency can make it hard to understand how a quantum algorithm is making decisions, which can be a problem for businesses who need to be able to explain their decisions to customers or regulators. For example, if a quantum algorithm is used to decide which customers to upsell, it can be difficult to explain why a particular customer was targeted. This lack of transparency can also make it hard to debug algorithms. If something goes wrong, it can be difficult to figure out why and how to fix it. This is a particular concern for mission-critical applications where the cost of a mistake is high. The third issue is accountability. Quantum algorithms are only as good as the data they're trained on. If the data is biased or incomplete, the algorithm will produce inaccurate results. In addition, quantum algorithms can be vulnerable to attacks that can cause them to produce incorrect or even malicious results. This means that businesses need to be able to trust the data they are reusing to train quantum algorithms. And they need to be able to trust the algorithm itself. But in many cases, it can be difficult to know whether or not to trust a quantum algorithm. This is because quantum algorithms are often seen as black boxes, meaning that it can be difficult to understand how they work and why they produce certain outputs. This lack of accountability can create problems for businesses, particularly when dealing with highly regulated industries such as finance or healthcare. So how can businesses navigate these tricky waters? One way is to work with a company that has experience in developing and deploying quantum algorithms. A good company will be able to help you identify potential bias in your data and develop algorithms that are transparent and accountable. They should also be able to provide you with the tools and support you need to monitor your algorithms over time and make sure they continue to perform well. In addition, businesses can also take steps to mitigate the risk of bias, such as by collecting data from a wide variety of sources and by using techniques to identify and correct for bias in the data. To sum up, quantum algorithms have a lot of potential to help businesses make better decisions. However, there are a number of ethical challenges that need to be addressed before they can be widely adopted. By working with a trusted partner and taking steps to mitigate risk, businesses can harness the power of quantum algorithms while protecting themselves from the potential downsides.